machine displays on both sides for you to check out. And upstairs on the second floor, you will find our art gallery. And that's showcasing all the creative applications. And who wants to snack? Who likes snacking?
Yeah.
Okay, we all hands. Love it. We are little snack monsters. So at 3 p.m., we have catering on the third floor. So we have some nice light bites for you. And after the panel, we will be hosting 2 quick Q&A sessions on the second floor. When I say Q&A, it doesn't mean you are asking me questions. I will be asking you questions. Think of it as a game show. Who likes prizes? Woo! So that is where the pop quiz will take place. Ask questions, you may win prizes. And before you leave, make sure to pick up your complimentary gifts from us, from MOVA Atom Form, that we will be giving away at the end of the event. So stick around, enjoy the experience, and don't miss out. All right, to kick things off, we are going to begin with our product unveiling session. And today we are so honored to have our leadership team here today who will be sharing more about the vision behind MOVA Atom Form and what's next for the brand. So please join me in welcoming our CMO, Zoe Shen, to the stage.
Good afternoon, everyone. I'm Zoe. Thank you all for being here with us today. Let me start with a simple question. Now we are living in a world where we can design almost anything. Why is it still so difficult to make it real? Because today, creation is still limited. Limited by materials, limited by colors, limited by fragmented workflows. What we imagine and what we can actually create are still not the same. And that gap has existed for far too long. Today, we are here to change that. But to change it, you need more than an idea. You need a real engineering, real iteration, and a real experience.
Oh yeah.
That's where we come in. Atom Form is part of the MOVA group. We started in 2023 with one clear focus: to rethink how creation should work. Over the past years, we've been testing, refining, and rebuilding from the ground up. Working across hardware, materials, and real-world applications. And behind all of that is a journey, the one we'd like to share with you today. Let us take a look at the memories together.
Go to my live and tell me if you can hear the audio.
And today, we are ready to move creation forward. So what does that make us? We are enablers of creative freedom. We believe tools should not define creation. Instead, they should expand it. And to make that possible, we focus on one thing: breaking the limits in creation. That's what we are here to do, using advanced technology to remove those limits, so anyone can turn ideas into reality. This is what we mean by creation on board. Not just freedom, but the removal of limits. No more switching, no more waiting, and no more wasting. Just creation, as it was always meant to be, growing, integrated, and unrestricted. And today, we take a major step toward that future. A future where multicolor and multi-material creation are no longer challenges, but simply how creation works. Now, let me introduce my partner, Jagger. He will show you what that looks like.
Woo! Jogger.
Thank you, Louis. Hi, everyone. I'm Jagger. Today, I'm excited to show you how we are thinking multicolor and multi-material printing. For years, we will all face the same trade-offs. Too much waste, too much time, and too much complexity. Filament gets purged, then cut. Or even worse, cut while still printing. It's inefficient, it's expensive, and it limits what you can create.
No
Some
problem,
solutions
Chris.
try to fix it, but at a cost. More hardware, more tool hands, and more expense. So we asked ourselves, what if we could eliminate purge entirely? What if switching materials didn't mean wasting them? That question led us to something new. A fundamentally different approach. We call it omni-element. Built on one simple idea, cut only, no purge. To make that possible, for the next move. So we redesigned the entire feeding system.
Thanks, Chris.
Dual channel feeding system. Two channels always ready. One exits, the other is always in place. No reload, no delay, just seamless, continuous switching. But filament saving and speed are only beginning, because true multi-materials printing is about handling materials with completely different requirements. High temperature engineered filaments, flexible materials, and high strength composites. So we built the foundation to support them all. A full enclosed chamber up to 65 degrees, a high performance hot end reaching 350 degrees. Hardened steel drive gears for consistent, reliable extrusion. And the dual fan system for heating, stability, and auxiliary cooling. This is what makes engineering grade materials for FLers in our color 300 printer. So we rebuilt the system, omni-element, dual channel feeding, and the foundation for the true multi-material printing. Now, when it all comes together, everything changes. Imagine this, you can print up to 36 colors in one single print. You can print 12 types of materials in one go. No wasted filament, no post-assembly, and dramatically faster. That's crazy, right?
Woo! Whoa!
And of course, none of this matters without reactive quality. So we built intelligent system to protect every print with vision calibration, nozzle locking confirmation, triple Z axis leveling, and ultra-precise FOC servo motors. So with 12 nozzles working as one, the result stays clean, consistent, and reliable.
All right, Hector, I get you.
And to make that consistency real, we built intelligence at every stage with over 50 sensors and 4 AI-powered cameras. Pilot 300 keeps an eye on your print every step of the way, watching, analyzing, and making sure everything stays on track. So that's the hardware, the system that brings multi-material printing into a whole new dimension. But here's the thing, great hardware alone doesn't unlock true creative freedom. What really makes it powerful is the software behind it. Because to truly make creation of both, every stage from design to print needs to feel seamless, intelligent, and connected. And that's exactly what we've built. So now, let me hand it over to Kelvin, who will walk you through the software ecosystem that brings it all together.
Thank you, Jacob. And hi, everyone. My name is Calvin. I'm product manager at OnTheForm, and I also lead the product for Autumnverse. So, as Jacob has expanded how we break the limits of the color and materials with this incredible machine. Now, I'm going to show you how we improve the printing experience with the software. First, let's talk about the slicing. OnTheForm Studio is more than just a slider. It's designed to make the process of 3D printing easier, smooth, and efficient. I'm pleased to show you 3 features as an example. First one, Print Queue. This feature is designed for the multi-part model. Generally, a multi-part model can only be printed separately, and you have to reset and resize for each part. It's slow and frustrating. With the Print Queue, you load everything once, we take care of the rest. Auto setup, auto slicing from part to a product in one flow only. And second, device management. It is built for firms and users who have multiple devices. With device management in OnTheForm Studio, you can manage all your printer on one screen now. No switching, no micromanaging, just assign, monitor, and go. And third, easy mode for slicing configuration. This feature is designed for beginners. We have integrated all the confusing figures and settings into an easy mode. By choosing this mode, you don't have to learn each setting, each meaning of the part. It will apply the best settings for your models automatically. No barriers to slicing now. So, from setup to print, OnTheForm Studio remove the friction for all steps. However, simplified workflow is not enough. To truly unlock creation, we need to answer a question first. We have to get models if people have great ideas but no skills of 3D modeling. And that's exactly why we built Autumnverse. The goal of Autumnverse is simple, to turn ideas into reality. And we are achieving this goal with 3 keywords. Empower, reward, and open. First, empower. We want everyone to have the ability to create. So we provide free courses and training sessions from inspiration to modeling and printing all covered. Also, we have powerful AI tools and generators, so we can go from photo or sentences to a printable model. Second, reward, because creating deserves a reward. On Autumnverse, once a model is printed or downloaded, you get money directly. No complex rules, no hidden limitation. And beyond that, we have printer promote with exposure, with support, and business opportunities. And third, open, because we believe 3D printing belongs to everyone. Every model on Autumnverse is free to download and print it. Also, it can be printed by any printer. No locking, no barriers. Just creation for everyone. So, when you bring it all together, the Panel 300 breaks the limits of the color and materials. The Autumn Foam Studio simplifies the process, and Autumn Verse unlock ideas. Together, this is what we call Creation Unbound, and a world that anyone can create anything. And that's all. Thank you so much.
Amazing. Thank you so much, Kelvin. Really appreciate that. Now, we would love to be able to kind of gauge everyone's experience here when it comes to 3D printing. Has anybody played around with a 3D printer? Okay, looks like everything nice. Okay, a little hoops there. Great. What are some cool things that you've made before? Shout it out. What was that? Did you say flexible dragons?
Oh, yeah.
Yes.
Wow, we have flexible dragons. What else have we made out there? Oh my gosh, we've got the Iron Man. Okay, this right here, we're actually going to be taking a look at that closer as well. Okay,
Hard
if you haven't
mouth.
tried to dabble in 3D printing, what are some things that you would like to make? Go ahead and shout it out. Anyone? Okay, we're gonna get a little bit organizer. Look, this is the thing, right? It's all about your imagination, and it's pretty much limitless. And that's what's really, really exciting about this whole technology. And we're gonna chat more about what that looks like in the near future. Okay, so we have a couple of things that I want to remind you. Today we have so many great fun things. Make sure to use hashtags, hashtag AtomForm or hashtag MOVA AtomForm. And also we would love for you to follow our Instagram at AtomForm_official. Tag us, hashtag us, get everyone excited out there. All right, how are we feeling today? Let's get a good little cheer. On some of these things because we're giving away prizes. Who loves prizes? Great. Now we are still going to be chatting a little bit. What are a couple of things that we are looking forward to talking about today? Oh, we are going to be chatting about. Great. So let's take a look at, we had our leadership team kind of go over everything. So we're going to actually put that in a big visual in this next short video that brings the product to life.
Video time, guys. Q&A coming up, guys. Who likes a good Q&A? Don't sign off. Look at these guys doing the chairs. Yeah, you do, Hector. The access, the foundation of flatness. What's 48 decibel sound? Hey, Facundo. Adam palette 3000.
How was great with
Yeah!
that?
Woo, woo, woo!
We have so many great visuals back to back for all of you. All right, we're gonna do a little pop quiz. No prize given just yet. I'm basically going to warm you up. All right, what is the theme of today's product launch?
Creation unbound.
Wow, can we say that with a little bit of enthusiasm?
1, 2,
It's right here. Like there's like the answers right there. Ready? 1, 2, 3.
Creation Unbound!
Right, and we are MOVA again here at Adam Form. Please follow us on our socials. On Instagram is AdamForm_official. Make sure to tag us, and our hashtags are hashtag AdamForm and hashtag MOVA AdamForm. Okay, who has gotten a chance to take a look at the live demos? Just a few. Okay, I'm gonna make sure we make all of your hands raised by the end of this, because we have our live demos, as you can see right there on the right. You can actually see 3D printing up close. And the way we're gonna be doing all that is also some more visuals, and we're gonna try to work with our experts on this whole industry and 3D printing. So let's officially begin our panel discussion.
Yeah.
So, as we had mentioned, today's topic is creation in transition, 3D fabrication, AI, education, and ownership. We are living in this moment where the way we're doing things is evolving rapidly. And what is used to require specialized tools and expertise is now very accessible to everyone, allowing creators like yourself, designers, and makers of all backgrounds to turn your imagination into physical reality, tangible. At the same time, AI, as we know, is moving fast track like this, right? It's accelerating how we design, iterate, and produce. So it really does raise a couple of questions for us when it comes to the authorship, the ownership of it, and the future of creativity itself. So today we brought a group of fantastic voices from hands-on creators to industry and design perspectives to explore how these technologies are shaping the future of making. So please join me in a warm applause for our panelists to the stage. Robbie Burst from Robbie Does Things. We have Barry Cates, who's an adjunct professor at Stanford University and California College of Arts and Sciences. And we have our Jerry Gomes of the Print House.
Cherry, cherry, cherry.
And we have one more, if we can get. We've got Robbie Birch. Joel.
Good old Joel.
Joel Telly, that's right, a 3D printing nerd. Great, thank you.
Ruined his
Let's get
moment.
one more applause for our panelists, and we're about to get a discussion. Woo!
All right, here we go, guys.
Okay, come and take a seat. We are going to start with a quick round of introductions. And I'd love to invite all of you to briefly introduce yourself and your background.
I don't know how to do it, Josh, I'll be honest with you.
When it comes to 3D printing, as well as design and creative technology.
Awesome. Well, thank you guys so much for having me here. I am so excited. I actually met this company at CES this year, and their device blew me away. It looks so cool, especially because of kind of what I do. To kind of give you guys an explanation, just like today, Creation Unbound. You know, I'm just a childhood kid who's making his dreams into a reality. I mean, I started this thing, and as a kid, I loved Marvel movies, stuff like that. And so I saw one video of someone who built an Iron Man mask, and I was like, you can do that with a 3D printer. So I kind of do this thing where I just like order all the parts, and I have no idea how to do it, and then I just watch a lot of YouTube on how to do it. And here I am now. I've built some incredible things, and this 3D printing has just been an incredible outlet for me to kind of, I remember the first time I printed something, I put it to print, went to bed, woke up the next morning, it was there. And there was something that unlocked in me, just an idea that just hadn't stopped since. And it's been a year now, it's just been incredible. So thank you guys so much for having me.
Woo!
Inspirational. Nhiều mình họ chào cơ bài về thì there are a few Chinese speakers in the audience.
Oh, showing off.
Continue in English. I'm Barry Case. I've worn a number of different hats, about 40 years in the School of Engineering at Stanford in a design program, another 20 years at California College of the Arts in industrial design and interaction design. And probably of greater relevance to this conversation is about 20 years spent with IDEO, one of the world's leading product design and innovation consultancies. So unlike folks like you who actually do stuff, I've had the, I think, privilege, not of using machines, but of standing over the shoulders of designers and engineers for the last 40 years and watching the evolution of reproductive technology. So what we're seeing today is pretty astounding.
Ooh,
Hi everybody, I'm Joel, host of 3D Printing for nearly 11 years. My background is being a nerdy tech guy. I started out doing tech support for software companies, moved into quality assurance and development work and software development. And the final job I had in software was with Adobe on the After Effects team. And as the story goes, I got my first 3D printer for Christmas of 2014. They blew me away, and within a short amount of time, I remember I had lots of them. I had started a channel, and eventually I had to quit my full-time job in software to be a full-time content creator. And that has somehow led me to San Jose today with Adam Foreman. I'm excited to be here.
woo, 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 woo.
Hey everyone, I'm Jerry Gomes. I have a show on YouTube, The Print House. I primarily focus on 3D printing reviews and kind of just look at the technology and how it's progressed over the last 6 years. I also, I kind of have a small print farm myself, so I've designed some custom parts to fix products that are broken with manufacturers that don't sell replacement parts, and so I sell those online. This way people can bring their machines out of the dust.
Woo, woo. Oh, are they Crocs? What are those?
Seems like you have kind of already touched on
Yeah, they probably are.
just to start off nice and easy. What are some out of the box and starting?
Josh, you should print your own socks, dude. That'd be sick.
I mean, I think starting with stuff like this, just seeing stuff on the big screen or seeing stuff online, and then being able to actually do that, we could literally just go on Google, look it up, and then send it to print, and it's there. I think that's one of the biggest things.
One of the most startling things I've ever seen with 3D printing was at Seattle Children's Hospital, where doctors and technical staff can 3D print replica tracheas of children so they can practice surgery techniques, and then not just practice the techniques, but then using simulations, they can judge the airflow of the fixed tracheas to see which surgical technique would be best for the child. And then with that data, they can operate on the child and know that what they're giving that child is the best way forward.
Wow.
And picking up that, that's incredible. My father dealt with pancreatic cancer for a while, and so we kind of looked at all the different technologies, and 3D printing is one that's been incredible for that. And because pancreatic cancer is one of the hardest to cure, you normally have to do surgery, and so there's companies that 3D print actual pancreases with the exact same types of materials and stuff, so they can actually practice the surgeries on to see if it's successful. So it's just incredible.
Stuff like that's kind of wild. Yeah, no, I mean, that blows me away. I know, like, for me, the way I actually see it, and I already touched on it, is these being able to design parts and print them in your house, in 40 minutes or an hour, and have a machine that just works again. For instance, like the parts that I print, they're for a $400 or $500, it's for a cat litter box, but it's a $400 or $500 machine. And if it breaks, the manufacturer requires you to just buy a brand new one. And that's not cheap, right? So if you could just go to your computer and design a replacement part and then print it for 15 cents, I don't know about you guys, but I'd rather pay 15 cents than an extra $400.
I see just such an incredible range of applications now. I almost don't know where to begin. I've seen architects using 3D printers to create building materials. We're on the verge of using them to print buildings. I've seen bioprinting, as you have said, Robbie. We are on the verge of being able to create not something that looks like a human ear, but can actually work like a human ear, using biological materials. I've seen industrial designers creating forms that literally could not have been created in any other way at any other time, with hollowed out interiors and complex lattice exteriors. So we are in the process of seeing something truly remarkable take shape.
Thank you for sharing such specific examples, by the way. I think that's the thing where you can spell it out in a more layman's term that everybody can really understand how beneficial 3D printing can be. Now, this can kind of feel intimidating. What are some ways that maybe like an everyday person can like start into it when they maybe don't have any engineering or tech experience?
I think if you look back, maybe 5 or 6 years ago, 3D printing was pretty intimidating, but with a lot of different auto calibration features that we're seeing, 3D printing is very approachable. I know on the printer, you can just click a button and it'll do an auto calibration, and you watch it, do some funny bed probing, and it'll vibrate a little bit, and then it just prints. So yeah, and if you still seem to have problems, there's a lot of people online that have had the same problems that are good educators and can explain, like, oh, if you're seeing this, try this. So, and all that content is free.
Yeah, and kind of piggybacking off of that as well, I mean, I'm newer to 3D printing, and I remember when I got my first printer, I had to do manual bed leveling, and basically what that is it has to be a completely flat bed in order for it to print right. So in the past, you had to manually level everything, and then nowadays you can buy a printer like this, literally almost ready 5 minutes out of the box, and then print your first thing, and it's done. And so it's become incredibly approachable. So we have no idea what 3D printing is or anything about it. You can just order one and then it pretty much do everything for you. You just got to find a cool picture of what you want and boom.
I think part of what has made it more approachable is that we've seen more adoption. Just year over year, more people have known about 3D printing. And as a personal example, we have more 3D printers within the education system at lower levels. It's not just a university machine. It's a high school machine, it's a junior high school machine. I know teachers in the elementary school setting that teach kids beginnings of CAD using Tinkercad because it's web-based and it's free and it's easy. And these kids, through their teacher, print out their designs. And they're like 6, 7, 8 years old. And so I think that the way that 3D printing becomes more approachable is just what we're currently doing is we're introducing it at a younger age. We're making it more accessible at a younger age. And we've got more people like Jerry here making incredible parts to fix the things around the house. And so those kids now with this superpower of 3D printing will realize, hey, if something broke in the house, I can look for it. And they'll find him and his parts, and then they'll print them out. And then the next thing that breaks, they'll be like, maybe I can design that. And then they'll design it, and then they'll release it, and then someone else will find that. And so I think we're on a good upward trajectory.
We are, but I think we also have to recognize that we are changing the rules of the game in rather profound ways. So one of the presentations, and I'm sorry I forgot the name, was it Calvin, who presented the software interfaces of the atom form, left us with the question, or started with the question, where do ideas come from? So we're right now in a situation in which giving form to your ideas, as you say, is approachable, it's intuitive, it's easy, it's relatively inexpensive. So then the question really goes back to, what are you going to do with it? Where do those ideas come from? And what kind of a world are we now preparing to build for ourselves, since the tools have ceased to be a limiting factor? That, I think, is a really profound question for all of us.
Well, we're going to actually be able to segue into what has history in the past told us about where we are today with 3D printing.
Say that one.
Yes, I just wanted to segue in terms of like what has history shown us about like where we are today with 3D printing.
How much time would be on it?
Well, according to the clock, about 15 minutes.
Okay, yeah, don't ask an academic a question like that. So, I'll try to do this very briefly, but here's a quick thought. For almost the entirety of human history, everything that people made, used, owned was handmade and one of a kind. So for a couple of 100,000 years, literally every object in the world was unique. And then we went through this thing that we call the Industrial Revolution, with production lines, assembly lines, division of labor, steam, and then electricity, and then the computer. And we suddenly moved into a world in which almost literally everything that you own is mass-produced, exactly like the one that was produced before it, and exactly like the one that came after. So your Model T Ford, your McDonald's hamburger, your Macintosh computer, indistinguishable from the one that came before and the one that came after. And now we appear to be in the midst of the next truly epical transformation in which we are going back to a world which is characterized not by sameness, but by everyone potentially being different. That is an enormous civilizational change.
But everybody being different, I'm glad you brought this up, because if we take what you said and we kind of expand upon everybody being different again, like hundreds of thousands of years of history before us, everybody's being different, but everybody's being given the unique opportunity to make their own Model T Ford and to have their own automation platform. So we're getting uniqueness, but mass-produced.
Along those same lines, I think it's interesting to note that with 3D printers, and we have them in our house right now, if you wanted something, say, 15 or 20 years ago that was plastic or injection molded, it would cost tens of thousands of dollars to make it. Now with a 3D printer, we can make it in our house for literally 10 or 15 cents.
Yeah.
And you can have it today.
Let's chat a little bit about ownership, because this is kind of veering on that a little bit. We talked about how things were individually made, mass produced, and now we get a little bit of a hybrid of that with the innovation of 3D printers. How can creators out there protect their work in this new environment?
The way to protect your work is just never put it online. Never, ever. And that's just like that isn't a unique problem with the ideas that 3D printers then produce. Like anytime you have an idea and you put it in front of an anonymous global audience, it's no longer going to be uniquely yours.
Yeah, that's a difficult problem to solve. I guess you have two routes, right? The first route is to never put it online. And if you do that and you want to share the idea or the model, then you would have to be the one to print it and to hand it out, which some people, they want to be able to print it themselves. And so in that case, maybe you need to go learn how to do the design work. And it's a difficult problem to solve. If you put something online, we have a lot of databases where you can go download free models. So if you upload it for free and tie your name to it, then we need to find, as a community, some way to really, truly put some kind of licenses that can't be broken or can easily be, you can find the models online and revoke it if that person wasn't the original creator. So it's a big problem to solve.
Once again, we're in a situation in which a new technology is changing the rules of the game. So if I can share with you just a charming little anecdote. Some years ago, I interviewed Ricky Saul-Berman, who attended the TED conferences. And he said something that I thought was really clever, and I said, Ricky, can I quote you? Of course, with full attribution. And he said, you can quote me, but no attribution. And then he added, I don't believe in copyright. I believe in the right to copy. Think about that.
Yeah.
So I think that what is going on here is touching upon old systems of intellectual property, legal ownership, exposure, patent rights, all of which are being undone as we speak. And some of them, I believe, will have to be abandoned, good riddance, and others will have to be renegotiated from the ground up.
And I think off of that, all of these models that I build, I sometimes design them myself. Most of them are designed by incredible 3D modelers. The way that I attribute that is in my videos, I make sure to shout them out. I message them, say, hey, is it okay if I put this out there? I just want people to be directed towards you. And I think in this space, that's the best way that we can do that and protect that, but it's a really hard problem to solve.
Can patents exist in a free society?
Can a free society exist in a world of patents?
These are a couple of questions. Sometimes it feels like a catch-22, doesn't it? Right? But I think with any technology, there's going to be an evolution when it comes to what you can do and the regulations and the deregulation of things. What is still preventing 3D printing of becoming the default manufacturing process?
3D printing is great because it's a tool. It's a manufacturing tool, but again, it's not going to do everything better. There's always going to be traditional ways, at least as of now, that are producing better things than what 3D printing can make. So if you have a project and you want to 3D print the whole thing, I mean, go for it. But a lot of times there are projects in mind where 3D printing can handle 80 to 90% of it, but screws and nuts and bolts and leather straps and really strong pieces of like polycarbonate. That is going to be things that traditional manufacturing is going to make better. I mean, that may not always be the case in the future, but I think if we treat 3D printing itself as a tool and not the only tool, I think we make better things.
Yeah, there's also, it is a tool, right? So if you look at traditional manufacturing like injection molding, for instance, if we compare 3D printing to that, we have additional costs with 3D printing. For one, with traditional injection molding, you're using raw pellets to 3D print. Standardly, we're taking those raw pellets and we're converting it into filament, which is a pre-process which has a cost associated with it. And also a lot of the materials that we're printing with right now, specifically the consumer space, they definitely aren't as strong as other plastic materials that we can injection mold or use some other form of manufacturing.
I know the limits are probably more from our collective imagination and possibly from laws and patent arrangements and things like that. I think, as a part of a way to think about your very good question, there are so many different levels of application of 3D printing or instant manufacturing or whatever we choose to call it this week. So it's going to range from hobbyists who are doing totally cool things like that, or perhaps grade school kids doing Christmas tree ornaments, to work in the medical profession, which Robbie described. Within my own industry, within the design industry, it has fundamentally transformed the nature of prototyping. So we are not yet using it in manufacturing per se, but when I started hanging out in the design world, I was watching people in the model shop using bandsaws and sandpaper, and then it evolved into more and more sophisticated stereo access CAD/CAM machines, and now we have gotten to the point of being able to accelerate the creation of a prototype to a matter of hours, often of exceedingly complex forms, saving clients a huge amount of money, and turning prototyping into something that it's just never been before at all.
Yeah, and I just think off of that as well, like in the past, it's been, research, and then you plan and you figure out how you're going to do it, it's a final product, and now it's research, prototype, research, prototype, research, prototype, keep going, keep going. You can even do it same day. I mean, depending on what you're doing, it's a constant battle, and it's also just the thrill of it. It's exciting. It's like, hey, how can I fix this? How can I do this? And as we've said, it's become so accessible that it's this same day type of thing. And so the prototyping world has completely changed.
If you haven't had an opportunity to look at some of these, it's magical just seeing these forms emerge out of the box almost immediately.
And so Barry had mentioned things about complex shapes. Something you get with with 3D printing that you might not be able to get with traditional manufacturing are, for instance, these shoes, they're 3D printed, and the lattice structure of these shoes would be physically impossible to create with injection molding or any other standard manufacturing process. The only way that these could be produced would be with a 3D printer.
And that's really cool to hear because the prototype process can be bottlenecked from inventing something or creating something new. It gets really bottlenecked at that process of like the prototype and sending it back, all that. So on that note, what are some challenges when it comes to creating, like say, a prototype from scratch?
Well, I'll throw out one, and I think my new friends will argue with me a little bit. Some of the challenges are not physical or technological. They are what I'm describing in the level of ideas. So a big challenge is some guy who decides he's going to 3D print a disposable gun, or a toxic pharmaceutical, or an untested pharmaceutical. There are very few examples that I can think of in history, like none, of a new technology not having consequences that we wish we could stuff back into the bottle, and we can't. So that is a reason to proceed with excitement and with caution.
And education. I think how we battle that is education, because the creation of it isn't the bad thing. It's the use of the bad thing. It's the use that creates the badness. And I think if we educate, I think we get a benefit from the education that happens to young people early on because they know and respect the technology and they're able to utilize it for good.
For me, a bottleneck in prototyping or design work is just the barrier of the software that I'm designing in. If there's some new kind of form that I'm trying to create, you will find me with a different tab open on YouTube, and I am furiously searching, how can I do this? Whether it's a twist or that's some odd design form that I haven't tinkered with before. And that's the barrier for me. And you learn these designing softwares, and every day you design something new. And you grow your skills, and you get better and better. You need to pull YouTube up less and less, but there's always something.
And I think because of that and stuff like that, it also comes at a mental block as well. Like, if you would have told me 2 years ago that I'd be doing this and be able to do this, and the people who watch my videos are like, how in the world do you do this? I'm an engineer, like, I don't know what you're doing, like, all this stuff. And I think the truth is, it's a mental block. And as I said, when I first got a 3D printer, I remember went to bed, woke up the next morning, and something unlocked my brain of these ideas and this constant build of like, can I do that? Can I do that? Well, now I can try. I can at least try and figure that out. And so I think it's just taking that first step of, hey, how can I do this? How can I approach it? And I think 3D printing is one of the best ways to do it.
We touched on so many things that we could have branched into so many different conversations. We have a few minutes for maybe one more question here, and then we will be turning it to the audience. So if you've been brewing with some sort of question that you'd like to ask our panelists, feel free to get ready because I will have mic runners on the side to run the mics for you to be able to ask our panelists here. Let's talk AI because that is a technology that's become so everyday for everybody. Like, people are using AI very easily and accessible. Where does AI meaningfully improve design or manufacturing workflows, and where does it remain lucid?
AI is a very, very difficult one. I use AI in my daily workflow, and it scares me how good it's getting. The way that I see AI with 3D printing right now is probably more in like toy space, or if you're doing hip-hop gaming like D&D. AI can generate a lot of seriously impressive models, which would appear to be, hand sculpted. Truly remarkable. I've seen some people try to use AI to design more geometric things, like whether it's locks for a cabinet to keep a baby from opening. I mean, custom things like that, they're geometric, it maybe struggles with, but more organic shapes, it's shockingly good.
I think that with design and AI, let's just, the moral questions behind AI and design, let's just set that aside for now, because we don't have that much time. But with AI and design, I think one of the limiting factors is the breadth of different AI language models and the rate at which they're updated and the rate at which they do certain things better than the other and the way in which we have to interact with them. There are so many different AIs that you'll talk to anybody else, like, oh, this one is good for this, but this one is good for this. This one can do this if you get a prompt from this one and move it over. So I think we're going to have a very AI-centric future, whether we want it or not. I think it's going to go down into education and just letting people figure out how to use it as a tool to improve their daily life.
Provoking me with this education business. Joel, I'm really glad that you used the word interaction there. It is widely believed that about 99% of AI users are using it as a kind of a souped-up version of Wikipedia, kind of a question and answer thing. Where do I find this? And we're planning my itinerary for this trip. We have to be learning to use it in an interactive way and to figure out what we as humans can do to not extract information out of AIs, but to enhance our own thinking and doing capabilities through an interaction with this astoundingly, as you said, shockingly powerful set of tools. That is just barely happening, but as an educator, getting back to that again, I'm very much inspired by a quip from Buckminster Fuller. You guys know Bucky Fuller? Great iconoclastic American inventor. When he was working on his tear-shaped Dymaxion car, he said the point is, don't resist, don't fight forces, use them. And I think that that's a really good motto for everybody approaching an inevitably expanding new technology like 3D printing.
Great, so we actually have a few moments to do some Q&A. Does anybody out in the audience have any questions for our panelists here? Yes, let's run the mic over here to you first. Can we, anyone run the mic? Thank you very much.
What is?
We'll get that started.
What is?
Can we turn on his mic for Q&A? Thank you for your patience.
Hello?
Oh, it's all good. Or you can go ahead and say it out loud for us then.
What is the #1 standout feature for you of this new printer?
Okay, the question is, what is the #1 standout feature on this new printer, the PAL 300?
I love that you asked that. I think the coolest thing is the Omni, I don't know what that term though. The nozzle thing, that's the coolest thing. Yeah, I mean, that is incredible. That's very new, very new.
So to go off what you're saying, the that rotary turret nozzle switchery thing, I don't know the name of it. It is very impressive for multiple reasons.
Yes, there's the demo after this.
I actually just saw this printer in Shanghai last week, and I learned that I got to talk with some of the developers in detail there, and I learned that those nozzles can be used for more than
I don't know.
colors.
Ask.
For instance, if a nozzle falls,
I mean, you would need
the sensor can
the particles of it.
And swaps a new nozzle. Whereas with a traditional, or I shouldn't say traditional, with a, some other branded printer that doesn't have this feature, it would just pulp the print. And I've been known to go to work for 8 hours and then come home and the printer's not printing, and I'm like, well, there's 8 hours lost. With this, it would just change to a new nozzle and keep going.
For me, it would be the promise of minimizing or eliminating waste.
Yeah.
Which is, I think, one of the major challenges of our civilization.
I like the 36 filaments or 36 colors. Being able to hook up 6 of those 6 filament boxes to the machine, and I don't have anything in my head that's 36 colors, but I think if we have 36 different shades available, the amount of really cool prints that we make with mixing hues, or like with Hue Forge doing it, like we get closer to FDM being able to make almost like picture quality.
So I have done a 20 color print before, and it took me multiple hours to figure out what to make what color. To me, it's not the fact that you can do 36 colors in one print. It's the fact that you can have 36 colors loaded into the printer, and then when you go to print your model, you don't have to actually load all different materials in. They're already there, they're already loaded. You just select it in the slicer and in the software, and it does the rest for you. Because I've got a huge wall of filament. I'm not using the same. I have a huge wall of filament, and if I could just store them in like the RFD6, and then they're just all connected to the machine, it'd be wonderful. Never have to load another filament again.
We have time for one more question. Yes, can we run the mic over here?
I'm from Texas, I can talk. So, from your experience, is there any issue with like an item doing the intended thing it's meant to do? Like, so say you wanted to make like a step stool. How do you know it's going to be able to carry the weight? Like, how do you know that the thing you want to make is going to be able to do the intended job?
You step on it. No, I mean, if we had the talk of prototyping earlier, and what's really cool with additive manufacturing, you can print things really fast, usually pretty cheap. So you get to prototype and test. You can print your stool, you can step on it. If it breaks, you know that you need more material or you need to change the design. If it just creaks a little bit, maybe you and a friend step on it to see what the limits are. You could just iterate the process in going to print with it. That would be how I would approach printing a stool and making sure it worked for intended purposes.
Yeah, and I think just researching the different types of materials, as well as when we talk about in the slicer, in the software, you're able to change, how dense it is on the inside. What kind of strength do you want on it? Do you want something to be lighter or more? So it just goes all with the prototyping, but it kind of relays on that.
Great, thank you for those answers. We're about to wrap it up a little bit here. We'd love to get one takeaway from each one of you for everyone who's listening out there.
Man, I just want to thank the incredible team here for everything you guys have put on. This is incredible. I know you guys have worked incredibly hard, and you guys have been traveling everywhere. This is just incredible. And for those of you watching, I can't wait for this thing to launch. It's going to be incredible.
So my big takeaway is, in some respects, this is all very new. In other respects, we've been around the block on this a few times before. The invention of the printing press in the 15th century, photography in the 19th, sound recording in the early 20th, and then digital printing. I noticed that Paul Breinart, the inventor of the PageMaker, died yesterday. So in each case, there's been initial enthusiasm combined with panic, and then industries, institutions, legal systems have to grapple with how to adapt and adjust. And then the kind of third act of that three-part drama is dealing with consequences that none of us can at this point predict.
Wow. My takeaway isn't that deep, I'm sorry. My takeaway is really more in line with this 3D printing here from Atom Form. It looks really neat. I think it's got some cool tech on board. I just can't wait for it to get in the hands of people because they're going to use it in ways that Atom Form never intended, and they're going to create things that Atom Form didn't even think about. And I think that's going to be really cool to see.
I think 3D printing is, I think it's wild. I think it's definitely becoming very, very approachable. Anyone that doesn't 3D print right now, I would think would be able to purchase a machine like the Palette 300, be able to unbox it and start printing very, very quickly. And it's super fun, and I would really recommend people to just get into 3D printing in general. It's very, very, it's a very enjoyable hobby.
Amazing. Thank you for sharing all of this. We are going to capture this moment before we let you go. So can we grab our photographers to be able to take, just capture this memento. Let's get a round of applause for our panelists right here. Gather together for this quick photo.
Okay, 1, 2, 3. Okay, one more. Okay.
Amazing. Let's get a round of applause for everybody in the room. Here's Joel and Jerry. Be sure to follow them on all the socials. Thank you so
All
much.
the socials, boys.
So we had such a great conversation, kind of going from all the different spectrums of how this could look, right, from the history to the future. And we'd love to now invite all of you to really continue to explore the experience that we have here with MOVA Atom Form. Again, you can experience our products here on our first floor. So
I'm not going
you
anywhere.
can see how the
I'm
demos
gonna show you
work,
guys the
get a real good
demos.
up close look. But
We're gonna
also
finish up
upstairs
strong,
on your second
boys.
floor, make sure to
Probably
check
two
out our
boys in
art
here.
gallery. Then you can really see the spectrum of what we can make. And for those of you who
Take a
love to
picture
play
of Joe and
games,
tell him I'm his
little
biggest
game
fan.
shows, come by me because we're
I
going to
already
do
know
a
which
little
one Joe
quick
is.
Q&A up there at
Is it-
3:30, and we're going to give away prizes for all of you.
Prizes.
So, thank you for joining us here today. Feel free to move around, explore, and we'll be seeing you upstairs very shortly.
Sick. This is cool. So now we're gonna check out some demos, guys, I think. So let's go over to the demo section. How's everyone doing? Hector, thank you for being a trooper, staying in this thing the whole freaking time. Let's see. Check out some cool shiz stuff. Is it gonna print something? Are you guys gonna do a demo?
Yes.
What are you guys gonna print?
Sorry?
What are you guys gonna print?
What we're gonna print?
Can you like show us what you're gonna print?
Yes, we're gonna print a logo of CNET.
Sorry?
Logo. We're gonna print.
Oh, they're gonna print the CNET. Okay, cool. They're gonna print this right now. Sign. Oh, so I guess it printed all these things.
Sorry, we get a
Phone case.
So we are fixing it.
Yeah, no worries. Take your time. All these cool things. What is that? A microscaper for a robotic lawnmower. Got the educational gear examples. Hitting somebody. The journalist. This is the machine right. Can you guys hear me okay? Give me a ask if the nozzle capture device is the nozzle capture device a consumable good?
Oh, sorry?
Someone's asking me if the nozzle capture device is a consumable good.
Consumable goods?
Yeah, I don't know what that means. Do you? That, thinking that might, oh, like is it?
Should we resell the
That's the question. See the question on the screen?
Okay, let me take a look.
Yeah, it's the last
Ask
one.
if it also capture device is consumable goods. My way.
Do you know what that means?
Also capture device consumable.
Nah.
To be honest, I couldn't figure out
It's okay. No worries.
开始打了，打那个 Skynet 那个。
Live audience.
Yeah, but not that many people, only 6 people. Hi, I just met her. She's a fan. She doesn't have her own audience, but she's like a fan of 3D printing. What do you love about 3D printing?
I would love to print gold jewelry.
She wants to print gold jewelry.
That should be the future.
That's a good one.
So we are actually going to be making our way upstairs to.
So,
注意力，我看都跟那儿我自己没打。
I think, but regardless, let me show you